Good morning to Dr. Saiful, our lecturer. So we are from Group 1. We'll present our mini project with title Development of Bio-Degreaser. With our team member, we have Muhammad Adam bin Ahmad Arif with metric number TH225 and me, Abifillah Veles, with metric number TH244. And we also have Siti Nur Shafiqah Huda binti Muhammad Sharif with metric number 265. And last one, we have Elizabeth Jendon Anak Unchu with metric number TH267. So this is our outline of this presentation, which we have. The first one is the introduction, the economic analysis, and last one is the conclusion and recommendation. Let's start with the motivation of this mini project. The motivation of this mini project start with the usage of nonyl phenol ethoxylate, which also known as the NPE, and the volatile organic compound, that also known as the VOC, based degreaser that widely used in the industry because it was easy to get with reasonable price, or we can say it's more cheaper compared to other degreaser. However, this usage of this degreaser brings many disadvantages to the environment. First and foremost, the waste from the usage of degreaser will be disposed into the soil and water, which will bring harm to the aquatic life and soil pollution and erosion. Currently, most of the degreaser used in the oil and gas industry contain linear acyl sulfate, which is known as LAS, that is non-environmentally friendly as it is toxic and not renewable. So the main motivation is to produce the biodegreaser to save the aquatic system and the environment from serious pollution by the substance in the degreaser. Like I said on the previous slide, nowadays most degreaser used in industry, house, and house appliance contain harmful substances like NPE and VOC. So these non-degrade degreaser are harmful to the environment when it released into the water, and it is incapable of being chemically degraded over time and will remain in the atmosphere for a very long time. For example, like we have NPE. NPE is moderately soluble in water and have a half-life is more than 60 years, which it is very long. And then the researchers have been done on effect of the NPE on the environment by the Shoana. The textile industry has increased imports by 300% over the last 5 years. These imports contain the nonyl phenol NP and the nonyl phenol ethoxylate, which is NPE, which enter and contaminate surface and groundwater as well as soil. This shows that over the years, the amount of imported NPE has increased. That's for the NPE. As for the VOC, for the VOC, VOC can be found in a variety of consumer, industrial, and commercial items, but their buildup in water and air has drawn the most attention because this content in VOC, which for example we have trichloroethylene and vinyl chloride, are the most harmful and will cause a cancer to human. Research by David and Nicholson, 2021. So this shows that the main problem here is the usage of the NPE and VOC because it will harm the environment. So let's move to the objective of this project, which we have 3. The first one is we need to formulate NPE-free degreaser, eco-friendly, and also we formulate a VOC-free degreaser for oil and gas industry.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam, TH20025, and I will talk about the economic analysis. Right, so for the project cost estimation, we will find the cost of manufacturing. So first of all, we will find the cost of labor using the cost of labor, number of labor equation. So in this project, actually we will use the raw material will be mixed into the heater, and then it will be cooled by the heat transfer equipment. So number of equipment is around 2. So number of labor, we will get around 12 worker. So cost of labor, we will times by standard factor, and minimum salary in Malaysia is around 8 ringgit per hour. So after it been times by the standard factor, cost of labor is around 798,912. Right. So next is our project cost estimation. So cost of raw material. So we will use 4 raw material in this project, which is the first one is EcoServe LFE 635, second one is EcoServe EH9, third one is the one on TPNB, and then the last one is the NS water. So EcoServe, the first one, EcoServe LFE, we will use around 9%, which is around 900 kilo per hour. And then the second one is also 9%, which is 100 kilo per hour. The third one, the one on TPNB, is around 7%, which is 70 kilo per hour. And then the NS water, around 75%, which is 750 kilo per hour. So our manufacturing is production per day is around 24 ton, and then production per hour is around 1 ton. Okay. So for the cost of LFE, the price is around 98 ringgit per kilo. So after it been times by the steam factor, we will get around 50,930,640. So second cost of EH9, which is around 95 ringgit per kilo, and then the price we will get is around 71 million. So the third one is the one not dependent, which is around 95 per kilo also, and then the price we got after the steam factor is 55 million. And the last one, the nice water, which is around 0.0045 ringgit per kilo, and then after the steam factor, we will use around 28,000. So the total cost of the raw material is around 177 million. Right, the next one is for the cost utilities. So as I mentioned before, we will use two equipment, which is fire heater and the heat exchanger. So the fire heater required 26.8 gigajoule power with 80% efficiency, and the price is around $13.88, and we will convert it to Indonesia, which is 62.46 per gigajoule, and then the price for 1 year is 30 million. Right, so for the next one is heat exchangers. For the heat exchangers, we will get around the flow rate is 1754, which is 1.75 gigajoule per hour, and then convert it to Malaysian ringgit, which is 69.76 ringgit Malaysia per gigajoule, and then for a year, we'll use around 870,350 ringgit. So the total is around 40 million, which is opposed to 15 million. So for the project cost estimation, so our project will be the fixed capital, estimated total cost is around 20 million. So using the cost of manufacturing equation, we will cut the value of the cost of manufacturing is around 244 million, 253, 291. And then for our product, which is a bottle, is around 5 kilo. So 1 hour will produce 1 ton, which is divided by 5, so we'll produce around 200 bottle per hour. So 200 bottle per hour will times by the steam factor. We will get around 1,664,400 bottle per year, and then each bottle will sell around 300 ringgit. So our revenue is around 499, 500, half million, which is 500 million. Right? And then so our net profit is our total revenue minus by the cost of manufacturing, which is around 255,066,709. That's all for me. Thank you.
Hi, my name is Elizabeth. I'll explain about feasibility study on how to find the net present worth, NPW, and rate of return. First is net present worth, NPW. To calculate the value of NPV, we are using the equation NPV equals to P over 1 plus R to the power of N. So for this project, we will calculate the net present value for 5 years. So our N value is 1 year to 5 years, and then the value for R we assume is 10%, and cash flow is 255,066,709. And then calculate for each year, and then the total for the value for each year we will get 966,973,505 ringgit. Then calculate the value NPW using equation NPW equals to value NPV minus the capital cost, which is 20 million. And then we will get 9.6903,505 ringgit for our NPW. For rate of return, from the table, let's assume all the product are sold and we got 255 million from year 1 to year 5. Then calculate the rate of return, substitute the value into equation NPW equals to cash flow over 1 plus I of N. Then we got 12.75% for I value.
Assalamualaikum, sir. My name is Siti Nursyad Muhammad Sharif, and I will present about the return on investment, payback period, and also budget monitoring and controls. First, for return on investment ROI. In the previous slide, we can see that we invest 20 million in this project and earn 255 million, 66,709 ringgit. To calculate the ROI, the formula is net profit minus capital cost over capital cost. Our calculated return on investment ROI is 11.75%, which is a good amount. Next is for the payback period. From the graph, we can see that the payback period should be in the first year of the investment. Next is the budget monitoring and controls. I believe that setting up a trustworthy reporting system and putting an efficient communication strategy into place are critical during the critical project monitoring and control phase. These steps are essential to guaranteeing the prompt and effective distribution of project performance data. The project teams can expedite the decision-making and corrective action by facilitating the monitoring and controlling process through the implementation of a well-structured reporting system. Next, the deployment of a regular reporting system helps mitigate the challenges that may arise from human-related problems that could impede the flow of essential project data. By using standardized reporting procedures, organizations can lower the risk associated with miscommunications, holdups, and incomplete information. Ensuring that all stakeholders have access to up-to-date and precise performance data fosters transparency and coherence throughout the project. That's all from me. Thank you.
So let me conclude this mini project. In summary, the project exhibits strong financial viability and success as demonstrated by its healthy RM 255,066,709 net profit. The 499,320,000 in ringgit total income demonstrate the project potential ability to generate revenue. The outstanding net profit margin can be attributed to effective cost control, as evidenced by the cost of manufacturer (COM) of 244,253,291. So the project effectiveness in returning in the project effectiveness in turning revenue into net profit in relation to manufacturing costs is demonstrated by the profitability indicator indicators, which include a positive profit margin and return on investment, which is ROI. With careful attention to market dynamics and strategic financial management, the project is well positioned to grow further and make valuable contribution to the success of the organization as a whole. I think that's all from Group 1. Thank you.